All right, ladies and gentlemen, welcome to your video lesson on the quiz review. Hopefully you find this useful and you use it to prepare to do a good job on your quiz. All right, so we're going to start with a warm-up, which is also going to obviously serve as part of the quiz review. Our last class was section 2.5, and 2.5 was about compound inequalities. And remember, when we were solving compound inequalities, which is what we have to do in the first two examples here, we have to first determine if they are and or inequalities, okay? So the first one has two inequality symbols in it. And what we're doing is we're saying that what is in the middle, that 3x plus 6, is doing two things at the same time. It's got to be less than or equal to 3, and at the same time, it's got to be greater than negative 6, okay? So because we're comparing at 3x plus 6 to two things at the same time, okay, we have to use the and word, all right? So our connecting word here is and for those compound inequalities. Remember, and will always be written with two inequality symbols, okay? And then or, remember, or will always say or. So like by default, this must be and because it does not say or. So all that stuff, all those are ways you can identify what the compound inequalities are going to be. All right, now going about solving this, right? So what we got to do when we solve an and compound inequality is we have to first split the inequalities into two separate inequalities, right? And so I could split it into the first comparison that we see, right? So that 3x plus 6 is greater than negative 6. So I'll write that one first. And then the other one is what we're comparing that 3x plus 6 to on the other side. 3x plus 6 has got to be less than or equal to 3. So 3x plus 6 less than or equal to 3. And then all I do is solve these now individually, right? So the steps are the same for each of them. So I'm going to subtract 6 here. The reason I'm subtracting 6 is because, well, what's happening to x, right? Well, I'm multiplying by 3 and I'm adding 6. I have to undo those in reverse order. The last thing I said was add 6, so the first thing I will do is undo that by subtracting 6 from both sides. That gives me a negative 12 is less than 3x. And I'm going to divide by 3. And remember, it's not negative, so I'm not flipping the sign here. That'll give me a negative 4 is less than x. Or if I read it from the variable's perspective, x is greater than negative 4. All right, now I'll do the same thing here, exactly the same steps because it's basically the same inequality except for what we're comparing it to. So we're saying that we're going to subtract 6. I'll end up with 3x is less than or equal to negative 3. And then I'll divide by 3, and I get x is less than or equal to negative 1. Okay? Now, in order to write my final answer, all I have to do is put these back together using the connecting word and. Okay? So I can actually write this in two ways. The easiest way is to literally write exactly what you see with the word and. So negative 4. I'm going to actually write it with the variable first. So x is greater than negative 4. The word and then the other inequality. X is less than or equal to negative 1. The other way to write this is to kind of combine them into one statement instead of two separate statements. So x is less than or equal to negative 1, and at the same time, x is greater than negative 4. The other way to look at this is say that x is in between negative 1 and negative 4. And now when I go to graph this, okay, I have to graph each of them individually and then look for that overlap. Remember, on an and graph, we look for overlap. If I graph this one first, I have to have a closed circle on negative 1. So I'll fill this in, and my arrow is going to the left. This one, I have x is greater than negative 4, so I have an open circle, and my arrow is going to the right. Now, these will extend forever in either direction, but remember, I'm looking for overlap. So where does the overlap exist? It's going to exist between negative 4 and 1, so I will just connect those two, and my graph will look like this. This isn't the most beautiful graph in the world, but you guys get it. Okay, open circle, closed circle, just to be clear. All right. Now, for or compound inequalities, they're a little bit easier just because like there's no separating, and we can identify it easily because, well, it says or. So all I got to do is solve them individually, connect them with the word or, and then graph them as is. I will do that. So I'm going to subtract 2 from both sides to start this one. So 4x plus 2 is less than or equal to negative 22. What's happening to x? Be multiplied by 4, and I'm adding 2. How do I undo that? I subtract 2 from both sides. Then I'm left with 4x is less than or equal to negative 24. I divide by 4, divide by 4. I get x is less than or equal to negative 6. I did not flip the symbol there because 4 was not negative. Now I will solve this inequality. So negative 2x minus 4 is less than negative 6. How do I undo the first step? I have to add 4 to both sides. So plus 4 plus 4. So I'm left with negative 2x is less than negative 2. I will divide by negative 2. Now this time, because I'm dividing by negative, I will flip the symbol, and I get x is greater than positive 1. Okay, now all I got to do is literally connect these with the word or, and that's my final answer. Okay. Then graphing them, we just graph them individually. So, all right, x is less than or equal to negative 6. That's a filled in circle because of the line underneath and my arrow going to the left. And then x is greater than 1. That is an open circle and an arrow going to the right. And because it's or, I don't care about overlap. None exists anyhow. So this is my final answer graph. Okay, moving right along here. So in lesson 2.1, we talked about these things about terms and coefficients. Remember, terms are separated by addition and subtraction, and coefficients are the numbers out in front of the variable. Notice that requires a variable, okay? So terms for this, the first thing I want to do, always when I'm identifying my terms, is change all of my subtraction to adding the opposite. That just helps me keep track of signs, okay? Now, when I list my terms, all I got to do is like draw lines down the addition symbols, and I've identified my terms. I now have 4 terms. They are negative 4x, comma, ny, comma, negative 3z. Notice how that helped me keep track of my sign by changing it to add the opposite. And negative 8, again, keeping track of the sign by adding the opposite. Now, my coefficients, I'll abbreviate that, remember, requires a variable. So for that reason, I can eliminate 8 right now, negative 8, as a coefficient because there is no variable. All the other ones have variables, and now it's just the numbers out front. So it's negative 4, comma, 10, comma, negative 3. So those are the coefficients and terms for that expression. All right, the other things that we did in 2.1 were write expressions based on real world situations. So let's look at this one. Kenny went to the store to buy apples and oranges. He bought A apples at 50 cents a piece and R oranges at 75 cents a piece. Write an expression that represents his total bill. So this is something that you might want to put together if you're going shopping and you're buying a bunch of a couple things, right? And you want to figure out, how much I have this amount of money and this is how much I can spend. This is what I'm buying. This is what they cost, right? So my expression, remember, will not have an equal sign because expressions are not equations, right? So it won't have an equal sign. So if I go ahead and write this expression, A is apples, right? So I'll say it's 50 cents, 0.5, or you could put 0.50. A, right? 50 cents times the amount of apples plus 75 cents, so 0.75 R for oranges. Okay, and that would be my expression. A is apples, R is oranges. This would be my final answer. Common mistake there is that students would do like 50A plus 75R. Well, those people are saying that apples are 50 bucks a piece and oranges are 75 bucks a piece, which is ridiculous. So just make sure that your answer makes sense whenever you're doing some math. All right. Another thing that we did was we set up equations based on real world situations. So let's look at this one. This is actually something that I do quite often when I'm trying to figure out who I'm going to hire for any kind of service. So pay attention here. Company A charges $800 plus 16 bucks an hour. Company B charges $720 plus $21 per hour. At what number of hours will the charge by both companies be the same? I'm going to stop there for a second, okay? This is what we got. Company A and Company B, they both charge you money just to show up at your door, right? Company A is more expensive at 800 bucks to show up, but their hourly rate once they're there is cheaper, okay? Company B, well, they don't charge as much to just show up, but their hourly rate is more expensive. So when you're comparing companies like this and you're trying to save money, you want to figure out where you can save that money, and you want to hire the company that's in the end going to cost you the least amount of money, right? Quality aside. So, if it's not going to take very long, well, then company B is going to be your best bet because they initially charge less amount of money. But if it's going to take a really long time, then it's company A because their hourly rate's less. And if it goes on and on and on, they're going to charge you less per hour at a certain point. But there will be a point where both companies will be very similar in cost for an amount of time. That's what we want to figure out. It says, what will that charge be when they are the same? Write and solve an equation that represents the situation. So here's what we're going to do. We're first going to model company A, right? So company A charges money. How do they charge it? Well, they charge you $800 no matter what, right? And then they add to that $16 per hour. Company B, they only charge $720 plus $21 per hour, right? So both of them have an initial charge and an hourly charge like we discussed. Now, if I want to figure out when they're going to be the same, what I need to do is set company B equal to company A and then solve for the amount of hours, because that will tell me how many hours it will take for them to be the same. So the equation becomes 800 plus 16H, right? Company A is going to be equal to 720 plus 21H, right? And now if I solve for H, it'll tell me how many hours that'll be. So let's go ahead and do that. The first thing I want to do is gather my variables on the same side of the equation, right? So I'm going to subtract 16H because I will get a positive result, minus 16H. That leaves me with 800 is equal to 720 plus, what is that, 5? Yeah, 5H. Okay. Now I'll subtract 720 from both sides. That's basically a two-step equation, minus 720, minus 720. So that gives me 80 is equal to 5H. And I believe we get 16 here. I'm just going to double check. 80 divided by 5. Yep. So I divide by 5, H is equal to 16, right? So if they tell me, well, sir, the job is going to take 16 hours, right? Well, then it doesn't matter what company I hired. Let's just go with the most reputable one, right? If they only tell me that it's going to be 5 hours, well, there's no way that I'm going to hire company A because they're going to charge me too much. And then, company B will charge less overall, right? So I can make an informed decision now. So now it's asking me, well, what will that charge be? Well, all I got to do is plug 16 into one of these companies' values, right? One of these companies' charges. So let's just pick company A, right? So it'd be 800 plus 16. And if I substitute that 16 in, it'll give me the amount of charge. So 16 times 16 is 256. I got 800 plus 256 plus 800 is $1,056. So at 16 hours, both companies will charge you $1,056. All right, moving on here. All right, point 3 was about literal equations. Remember, literal equations basically have all variables in them. We solve a literal equation the same way we solve any old equation, except for sometimes we can simplify and sometimes we cannot. Okay, the steps are exactly the same, but sometimes you can simplify it, sometimes you can't. So now this one, in example 4, we're supposed to solve for V. So I'm going to go ahead and circle that to identify that's the one I want to isolate. Now, as I'm looking at this, there's like a problem here because it's in the denominator, right? So I have to think to myself, even if I do something like divide by m, this is still going to be in the denominator. So the question is, how do I get it out of the denominator? And the answer is to clear fractions, right? That is a strategy that we talked about earlier in the year, right? If I ever want to get rid of a fraction, I multiply it out by the denominator, and that's what we'll do. So I'm going to multiply both sides by v. Now, it might not look like we gained anything, right? Because v is now just being multiplied by d, and we didn't get like a variable by itself, but we did get it out of the denominator, and that's a step in the right direction. So what we're left with is v times d is equal to m. And now I ask myself, what's happening to v? It's being multiplied by d. So how do I undo that? I divide by d. So I get B is equal to M divided by D, and that is my final answer. Can't simplify it, right? You can't divide here and get some magical letter of the alphabet that no one knows about. This is our final answer. All right, example 5. We'll go ahead and solve this one for C. I got 5P plus 9C equals P. I'm solving for C. I have to ask myself what's happening to C. What's being multiplied by 9, and I'm adding 5P. So the first thing I will do is subtract that 5P. When I do that, I end up with 9C is equal to, I can actually combine these like terms. I can simplify here. P minus 5P is negative 4P. Now I will go ahead and divide by 9 on both sides, and I will get C is equal to 4P, negative 4P over 9, and I cannot simplify that, right? So this is my final answer. So remember, literal equations, you solve it exactly the same way, and then just try to simplify as much as you can, right? And in this, we could simplify in this little step here, but that didn't give us much, but it was a little bit, right? But in the end, we still don't get a variable equals a number. We don't get B equals 2 or C equals 5, right? And that's the case with literal equations. You don't get that kind of answer. Okay. So we also wrote equations that were related to, we wrote inequalities, right? So lesson 2.5 or 2.4 was about inequalities. So this is a example where we are going to take a word problem and write an inequality. So let's read it. Julie is buying 12 shirts for the drama club. She will choose a style for the blank shirts and then pay an additional charge of $2.75 for each shirt to have a logo, have the club logo put on. If Julia cannot spend more than $99, how much can she spend on each of the blank shirts? It says write an inequality to find the possible cost of each blank shirt. So this is a little bit tricky to figure out how Julia is spending this money here, okay? She's buying 12 shirts for the club. She will choose a style for the blank shirts and then pay an additional charge, right? So like we don't know how much each shirt costs, right? And that's actually what we're supposed to find out. It says how much can she spend on each of the blank shirts? But we do know that for every shirt she buys, which are 12, right? She's going to have to pay $2.75 for that logo put on, okay? So let's think of it this way. If I'm going to buy one shirt, right? One shirt. Let's say that one shirt is just B, right? Well, for that one shirt of whatever that cost is, right? One shirt cost, let's do this. One shirt cost is equal to B, okay? Well, now I'm going to also add, no matter what, $2.75 to that, okay? But here's the thing. I'm not just buying one. How many am I buying? I'm buying 12. So I'm basically taking this entire cost right here, and I'm multiplying that by 12. Does that make sense, right? I'm taking the cost of one shirt. If I buy one shirt, I'm adding $2.75 to that no matter what. And I'm going to do that 12 times. So it's 12 times that overall cost, okay? So I always like to set up my inequalities this way. I always like to break it down into like the simplest ideas of, all right, I have money that I'm spending, right? And I have money that I have, okay? And the reason I like to break it down this way is because I can easily think about what my inequality symbol is, okay? Well, how am I spending my money? Well, I'm spending my money at 12 times the cost of a shirt, which is B plus 275, which we talked about earlier. What money do I have? Well, I only have $99. So what inequality symbol should go right here? Well, it's got to be less than. I can't spend more money than I have, but I can also spend all of my money. So it's got to be less than or equal to. And now all I got to do is solve this it's not a compound, it's just a regular inequality, right? So I go ahead and start solving this. I'm going to go ahead and start distributing this 12. So I got 12B plus, let's calculate 12 times 275 quick. 2.75 times 12 is $33. That's less than or equal to now 99. Kind of shift that over there. So I'm going to subtract the 33 from both sides. That gives me 12B is less than or equal to 66. I will now divide by 12. And B is got to be less than or equal to 5. I'm going to move this up, 5.5. Okay? So what does that mean? Well, that means the blank shirt cost has to be less than or equal to $5.50. So her maximum price for a blank shirt is $5.50. She can certainly spend less than that, save money. This is the maximum cost. All right, moving right along here. So for these examples, what we want you to do is be able to recognize a graph and write a compound inequality, okay? So what we talked about is we first have to recognize if it's an and or an or, right? So or, and, which one is it? Okay, so remember, ands have overlap, right? So the initial graph looks something like something that goes that way, right? And something that goes the opposite direction, and they have overlap, but we eliminate where there is no overlap. So what we really end up with is like a connected line, right? And so for that reason, the top one here, we're going to say that that is an and. Now, if I'm going to write the compound inequality, all I have to do is go back and think like, well, what did the original one look like? Well, the original one had an arrow that was going to the left, or to the right rather, this way, right? And then an arrow that was going to the left, and we just eliminated where there was not overlap, and we only kept where there was overlap. So now all I got to do is write the individual inequalities for these, and then connect it with my word and. So here we go. This is x being compared to -5, right? And what are we saying? Well, it's an open circle, arrow going to the right. X has got to be greater than -5. And connect it with the word and. This is closed circle, arrow going to the left, so x has got to be less than or equal to +2. And that's all there is to it. This one is an OR graph, and again, kind of like by default, right? There is no overlap that exists. So OR graphs will always go in opposite directions, and this one does. Literally, all we have to do is write the word OR and then put in what each inequality is separately, right? So this one is x is greater than 0, no line because there's not filled in. And this one is x is less than or equal to -5, filled in circle, line underneath. I think that one's pretty straightforward. All right, last example here, and then we'll be done. And it's everyone's favorite perimeter problem. So let's get after it. Miss Paulson is building a patio with a perimeter of 92 feet. So I'm just going to put right away, P is equal to 92. Perimeter all the way around is 92. She knows that the length of the patio is, okay, so length of the patio is 6 more than 3 times the width. Label you a picture, write and solve an equation to find the length and width of the patio. So here we go. I know that this is, let's just call this my length, and let's see, where am I going to put myself here? Let's put it over here. Length, and then I got width and width, okay? Well, I don't know anything about the width, so I'm just going to leave that as W, but I do know that the length is, so I do know that L equals what? 6 more than 3 times the width. Well, that means that I take 3 times the width, 3W, and I add to that 6 more. My W is just straight up equal to W. I don't know anything about it. Remember, our perimeter formula is P is equal to 2 times the length plus 2 times the width. And now all I have to do is substitute all of that information into this formula. So what is my perimeter? I already said that it's 92 feet, right? Right there, 92 feet. So then I can say that 92 is equal to 2 times the length, which is 3W plus 6, plus 2 times the width. Well, the width is just W, so it's just 2W. And now I can go ahead and solve this for W. And once I get W, I can then find the length. So solving this, I have to simplify some stuff first. I have to distribute this to, 92 is then equal to 6W plus 12 plus 2W. Now I got to simplify this. 6W plus 2W, 92 is equal to 8W plus 12. And now I got to, so this is just a 2-step equation now. So I'm going to subtract 12 from both sides. I get 80 is equal to 8W 80. 80 is equal to AW. Now just divide by 8, and W is equal to 10. So the width is equal to 10, and now I can find the length by substituting that 10 into this thing that we figured out earlier. Length is equal to 3W plus 6. So length is equal to 3W plus 6. If W is equal to 10, then length is equal to 3 times that 10 plus 6. And then the length is equal to 30 plus 6, which is 36. All of this is feet. So there's my final answer. So 10,000 foot view of this problem. What did we do? We looked at this as a perimeter problem. We found out that the perimeter was 92 just by reading. We interpreted that the length was 3W plus 6 because it said that it's 3 times the width and 6 more than that. We don't know anything about the width, so we just says W equals W. This is our perimeter formula we've talked about extensively. And then all we did was substitute all that information in and solve the equation. All right. That is it for your review, ladies and gentlemen. I hope you guys have a great day. Take care.